So far, and up to the end of section 6 or part 6, we've been looking at functions of just one variable. They're relatively easy to sketch, and we wrote them as f of x, and typically we draw them, the value of f of x, as y. This means that when we want to take a limit at a point, say x equals a, all we have to know in order to know that the limit exists is that the value that the function tends to from the left and from the right is the same. Now, in section 7, we're going to be looking at something that's just a tiny little bit more complicated, which I'll separate here, which are functions of more than one dimension. Instead of writing f of x, a lot of them will be given by f of xy, and many times we'll write them as z. To visualize them, we can't just have two axes, but we actually need three. We need on top of an x and y, we also need a z. And it means that whatever function we'll be drawing, they will typically be surfaces and not just curves. It also means that when we talk about these functions, both x and y will be variables, and z will now be the function of x and y. And this will be really important when we look at implicit differentiation and partial implicit differentiation, where y will now be a variable. It will no longer be like before, where we assume it to be a function of x. But things will be very clearly defined and explained to you, obviously. If you're ready for it, let's then start section 7, functions of more than one variable, or functions of higher dimensions. In this section, we're not only going to have a look at functions of more than one variable, how to take limits, but also how to visualize them before we go to part 8 or section 8, where we look at partial derivatives that arise very naturally once you have more than one variable. You can also find in the lecture notes in section 7.1 a very important warning about notation. Up to now, we've been looking at functions which just depended on one variable, which we typically call x, and typically we write that y is a function of x. From now onwards, especially when we define functions of more than one variable, we will pick x, but also y as variables, and typically these surfaces will be given by a variable z. And there's nothing stopping us actually from going to even higher dimensions, and some functions will depend on, say, 3 or 4 or 5. And in this case, you'd probably have to call it something else and no longer z. The big difference is here y is the function, x is the variable. Here both x and y are variables, z is the function. Here x, y, and z are variables, and let's just keep it to f for simplicity, is the function.